All right, today we are going to talk about solving equations with variables on both sides. So our key idea for this particular section is obviously to collect the variable terms on one side and the constant terms on the other side. In example 1, we're going to look at solving an equation with variables on both sides. So this is going to be the most basic example of that type of problem. So in example 1, they want us to solve 15 minus 2x equals negative 7x. And then it also says to check your solution. Everyone's favorite part. So the first thing we're going to do is rewrite our equation. 15 minus 2x equals negative 7x. And I'm not going to highlight them like I do in class, but I will do my boxes and my squares. So I've got this variable term here and this variable term here, and then this non-variable term here. And what I want to do, without even looking at the terms inside of those shapes, I want to get my rectangles on one side and my circles on another. We always want to deal with the variable term first. So our variable term is first. Technically, we also want to always move the smaller of the two variables so that we're left with a positive coefficient of the variable. It's just kind of easier to deal with. So if I'm looking at the negative 2x and the negative 7x, the smaller of the two variables is a negative 7x. So I'm going to add 7x to both sides. That's going to give me 15 plus 5x equals 0. It's a little bit of an extra step because of the way the problem was set up, but trust me, you're going to be happy that you have that positive coefficient to deal with. So again, not even looking at what's inside, simply looking at the shapes. I have a circle and a rectangle and a circle. In order to get my squares on one side and my circles on the other side, remember it means the other side of that equal sign, or the other side of that line here that I put. So I need to move this over. So I'm going to subtract 15 from both sides. That's going to give me 5x equals negative 15. If you want to continue to do that, you can now see that you have successfully gotten your rectangles on one side and your constant or your circles on the other. Now I'm going to just continue to solve like we've been doing. So I'm going to divide both sides by 5. And I'm going to find that x equals negative 3. Next, I have to check. I start with my original equation. Followed by a semicolon and what I think the variable is equal to. Now I'm substituting this value of x for each of the variables in the equation. Now I'm following order of operations. Order of operations on this side tells me I have to do this first, so I get 15 plus 6. On this side, I get a positive 21. We're not done here. You can tell that you're okay here because you know that 15 plus 6 is 21. But you have to finish it out to say 21 equals 21. Not sure where my brain was there. Move this up just a little bit. So example 2 is using the distributive property to solve an equation. Now, if you remember in class, we went over kind of a detour, shortcut, a way to avoid it, however you want to look at it. And if you want to continue to use that method, you can. Sometimes it's easier to just do the distributive property based on what's going to happen if you don't. One of the problems that we did in class, it was easier to kind of go through and use the distributive property versus undoing that first. So in this particular question, or in this particular example, they want us to solve -2. That's fun. Sorry about that. -2 times 5 minus x equals 6 times 2 minus, this is a hot mess, 1/2 x. So if you undo the distributive property, meaning you divide by this, you're still going to be left with something out here. My thought is I'm going to go ahead and do it because by distributing the 6, it's going to let me get rid of that fraction. So I'm going to go ahead and do that. But remember, our first step is always to rewrite the equation. So I've got negative 2 x minus 5 equals 6 times 2 minus 1/2 x. So I'm going to distribute my negative 2 to the two terms inside that parentheses. So I get a negative 2x plus 10. Now I have to distribute the 6. So I get 12 minus 3x. Technically, 6 times negative 1/2 is negative 6 over 2. Negative 6 over 2 simplifies to negative 3 over 1, which then simplifies to negative 3. Now I can do my little rectangles if we want. So I've got a negative 3x and a negative 2x. I've got a 12 and a 10. Some of us like to have a line. So I need to move my smallest variable first. So a negative 3x and a negative 2x. If I think about a number line, this is more to the left. So that's the one I'm going to move. Remember, I'm undoing it by doing its opposite. So these cancel, and that's going to give me 12. Bring down my 10. Excuse me, I have negative 2x plus 3x is just simply x. Variable term. Constant, constant. Hopefully you're saying already in your head, this is what's going to move over here because I want to get my circle with the other circle so that I have my rectangles on one side and my circles on the other. If you want to think of it as I want to have on mine green on one side and pink on the other, however you want to look at it. So I'm subtracting 10. X equals 2. Kind of hard to see down there, so we'll move it up. And I'm sure it said it. No, it didn't, but we're going to check it anyway. So I have negative 2, x minus 5 equals 6, 2 minus 1/2 x, semicolon, x equals 2. Substitute. Order of operations. Remember, as you go through the check, you're not solving it like you solve to find the solution. You're simply using order of operations on each side to prove that the left side equals the right side. Up until now, we've only had to mathematically go through the left side. Now we have to go through both. Make sure you're not skipping any steps.